Hi students, these notes are an introduction to factoring, specifically pulling the GCF or the greatest common factor out of an expression. This week is just an introduction to factoring. Factoring is actually a very large and very important concept that you will need to do on your TSI exam and use in future math classes. So, the first blank we have here is we're trying to figure out what does it mean when we get rid of parentheses by distributing and then combining any like terms. This is called simplifying. And you guys have been simplifying for a long time. Your brains naturally want to simplify things when you see them. We simplify through a process called PEMDAS. This helps us remember the order to simplify, the order of operations, parentheses, exponents, multiply, divide, add, subtract. This is old stuff. What's new is this concept of factoring. And it's actually the opposite of simplifying. It means to find the factors that will multiply to make that expression. So right now you're like, I don't know what that means. We're trying to figure out what things will multiply to make this larger expression or larger polynomial. So what we say about factoring, it is the opposite, sometimes also referred to as the inverse, these are synonyms, of simplifying. So in simplifying, we get rid of parentheses. In factoring, we are putting the parentheses back in. So it's the opposite direction, or it's the opposite skill. Factoring and simplifying undo each other and can be used to check our work. So we're actually going to be using both in these notes. I know you guys know how to simplify, but to check our factoring work, we're going to simplify. So here's an example of simplifying. To simplify this expression right here, you would first want to get rid of the parentheses by distributing. Anytime you have a number or an expression outside of a parentheses, you want to multiply it by all the terms inside the parentheses, which is called distribution. So let's try it. 2x times x is 2x squared. If you recall, both of those x's have an exponent of 1. So when we're multiplying, we add those exponents, and that becomes a 2. Now we're going to do 2x times negative 5. The 2 and the negative 5 multiply to make negative 10, and we still have an x. So this process of going from here to here this way is called simplifying. What we're going to be doing is we're going to be starting here. We're going to be starting here, and we're going to be going backwards. And this is what our answer will look like. So it's the opposite of what we've been training our brains to do for a long time. It's going to feel really strange at first, but we can use simplifying, which we're more confident in and more familiar with, to check our work to see that we're actually doing it correctly. Let's try some examples. We have 5 examples. For each example, we are going to factor out the GCF for each expression, and then we're going to check it. GCF, you might remember from when you were little, refers to the greatest common factor. So those are factors of each expression or each monomial that they have in common. So we're going to pull that out. So I'm going to explain it in 2 ways. One, a way where you can kind of see what's happening, and then 2, we'll kind of talk about a quicker way to do it. So we're going to take a look at each of these monomials, and we're going to kind of rewrite them in another way so I can see each of their factors. So for 5x cubed, the only factors of 5, or numbers that multiply to make 5, are 1 and 5. So I'm just going to rewrite the 5. Now x cubed actually means x times x times x. So I'm going to expand that so I can see all of the factors. Plus. Now we have 25x squared. Well, I know that 25, if I think of numbers that multiply to make 25, 5 times 5 make 25, and 5, they're both prime. So 25 is the same as 5 times 5, and x squared is the same as x times x. And I should really put dots between all these. The last one, and I'm going to kind of redo my arrow. 45x. The factors of 45, here's a blast from the past. Think of some numbers that multiply to make 45. 5 and 9 may come to mind. 5 is prime. 9 is not prime. What are some numbers that multiply to make 9? 3 and 3 multiply to make 9. So the factors of 45, the prime factors, are 5 times 3 times 3. 5 times 3 is 15, 15 times 3 is 45. So 5 times 3 times 3 is the same as 45, and then times x. So what I want you to see right now, these three terms, we've just broken down into their prime factors, basically. What we're going to do now is see which factors that all three have in common. I see that all three have a 5. Okay. I also see that all three have an x. Now, what's left in the first term is 2 x's. The middle term I have 5 and x left over, and then the last term I've got 3 and 3. So there's nothing else that all three terms have in common. So what we're going to do, we're going to pull out what they have in common and write that down. They all have a 5 and an x. Okay, so what we're going to do now is we're going to put a parentheses, and everything that we did not pull out of each term, we're going to leave inside the parentheses. So for this first term, I pulled out the 5 and the x, so I'm left with x times x, which is x squared. For the second term, I pulled out a 5 and an x, so what's left is plus 5 times x. And then in my last term, I pulled out a 5 and an x, so what's left is 3 times 3, which is 9. So this is the factored form of this, okay? The 5x specifically, that is the greatest common factor. If I pull that out though, I've got to put what's left, what I did not pull out, in parentheses after it, okay? So this is my answer. Now what we're going to do here is we're going to check it. You always want to check it, and this will feel a little bit more familiar. So to check it, I'm going to rewrite it, 5x times x squared plus 5x plus 9. So this is the factored form. Okay? To check it, I'm going to simplify it. I'm going to actually distribute that 5x back in. We're going to multiply, multiply, multiply. Let's see what we get. 5x times x squared, remember there's an invisible 1 on the x, is 5x cubed, or to the third power. The 1 and the 2 exponents get added. Now we're going to do 5x times 5x, second term. Remember, this exponent has a 1. 5 times 5 is 25. For my variable, it's x, and 1 plus 1 is 2, so 25x squared. And now we're going to multiply the 5x times 9. 5 times 9 is 45, plus we have an x. This matches this, which is what we started with. So because it matches, that means I have correctly factored. This is a correct way. So you always want to check it. I know you guys know how to distribute. Remember, we're doing the opposite of distributing. Now let's talk about a way where we could do this where we don't actually do this step right in here, okay? Where we go straight from here to here. So what you want to do is you want to first look at the numbers of each term, 5, 25, and 45. And it's kind of like you're trying to figure out what's a number that you can divide into each of those. Well, they're all divisible by 5. So I'm going to pull a 5 out in front. That's where this 5 comes from. Now I'm going to look at the variables. We've got x cubed, x squared, and x to the first power. The most x's that all three terms have is 1x. I can't pull out 2x's because the last term only has 1, right? So the most x's I can pull out is just this one here, and I can put the exponent if I want to or not. So that's how you figure out what your GCF is. Then to figure out what goes in the parentheses, now we're going to see what's left. So for the first term, I pulled out a 5. The 5 is gone. And I took away one of the x's, so now I only have 2 x's left. That's where this term comes from. For my second term, I pulled a 5 out of 25. So basically, I divided 25 by 5, which left me with this 5. I also took away one of its x's, so now I only have just the 1x left. And then for the last term, I took out a 5, so basically 45 divided by 5 is 9, and I took its only x. So that's why 5x times parentheses x squared plus 5x plus 9 is the factored version. All right, let's try another example. So my two terms are 4x squared and 24x. And I need to pull out the greatest common factor and then leave what's left in parentheses. So I'm going to do it the way where we don't expand it into its prime factors. Let's start with the numbers first. 4 and 24. I want to ask myself, what is the biggest number that I can divide evenly into both of those numbers? And you might even want to write this down. What is the biggest or the greatest, that's where the greatest comes from, biggest number I can divide all numbers by evenly. And by numbers, I mean coefficients. So that's the first thing you want to ask yourself. So if I look at 4 and 24, I can divide them both by 2. I can divide them both by 4. The greatest number is 4. So I'm going to write that down. Now I'm going to take a look at the variables. I've got x to the power of 2, and I've got x to the power of 1. So the second question you want to ask yourself is, what is the most number of x's or variables that each term has? What is the most number of variables each term has? So it has to be from each term. You can't just look and factor out of 2 of the 3 terms. If you had 3 terms, it has to be of all. What is the most number of variables each term has? These are the 2 questions that you guys want to be asking yourself, okay, with each of these. So if I go back to my variables, I've got 2 x's in the first term, 1 in the last term. They both have 1x. I can't say they both have 2 x's because the last term doesn't. So 4x, that is my greatest common factor. Now I'm going to put what's left in parentheses. So to figure out what's left, I'm going to think, well, what did I take away? So from that first term, I took the 4 out. Basically, I divided 4 by 4, which is 1. I don't have to put the 1, but I could. Don't have to. And I also took out one of its x's, so there's 1x left. Now you could also think of it like this. If I was to check it, which we'll do in a minute, and multiply 4x by the x that's inside, I should get 4x squared, and I do, right? So you can kind of ask yourself that as you're going. Now let's look at the second term. I took out a 4 and an x, right? So 24 divided by 4, that's 6. That's what's left. That's the factor that's left. And I took away the only x that it had. So this is the factored form of 4x squared minus 24x. Now to check it, we are going to simplify. Remember, simplifying is the opposite of factoring. So you're going to rewrite what you think the factored form is, and then to check it, we're going to distribute. Here we go. 4x times x. I'm going to add those exponents. Remember, when we multiply, we add exponents, so 1 plus 1 is 2, so I get 4x squared. And then 4x times negative 6 is negative 24x. This is exactly what I started with, so that means our factored form was correct. Alright, let's look at this guy. So if I want to pull out the GCF, or the greatest common factor, first we're going to look at just the coefficients. What is the largest number or factor that I can divide into each of these numbers? So to do this, I'm looking at 14, 35, and 28. What are some numbers that they can all be divided by? Well, I know they can all be divided by 7. 7 times 2 is 14, 7 times 5 is 35, 7 times 4 is 28. For some of you, this part might be easier than others. For those of you who don't know your times tables, it might be a little harder. You can just kind of guess and check on the calculator. Okay, so for me, I think 7 is the largest number that I can pull out of, out of the numbers. Okay, so I'm going to write down 7. Now I'm going to look at the variables. I've got n squared, I've got n to the first power, and then I have no n's in the last term. Because there's no n's in the last term, I cannot pull out any variables. They all have to have at least one. So I don't have to worry about that. So we're going to leave the variables the same in each term inside the parentheses. We're just going to put the leftover factor. So for the first term, 14 divided by 7 is 2. So we've got 2n squared. Second term, 35 divided by 7 is 5. So minus 5n. Last term, 28 divided by 7 is 4. So plus 4. All right, so this is what I think my factored answer is. The GCF of this would be this 7. That's actually the GCF. The whole thing that I boxed would be the factored form. So to check it, let's go ahead and we're going to simplify our answer. So rewrite it. 7 times parentheses 2n, oops, not x, 2n squared minus 5n plus 4. We're going to distribute the 7 to each term by multiplying. 7 times 2n squared is 14n squared. 7 times negative 5n is negative 35n. And 7 times 4 is 28. Compare this with what we started with. Yes, they look exactly the same. That means my factored answer was correct. Here's another example. So, first thing we're going to do, we're going to take a look at all of our coefficients. We've got a 1 in the first term. We've got 24 in the second term, 12, and negative 4. So here's the deal. If one of those coefficients is 1, the greatest common factor is always going to be 1 then. Okay? That's it. You can put it or you don't have to. Alright, so now let's look at the variable part. We've got g to the 4th power, g to the 3rd power, g to the 2nd power, and then g to the 1st power. We want to ask ourselves, what is the most g's that all 4 terms have? The most g's that they all have is just 1. So now we're going to put what's left in parentheses. Basically, my coefficients are going to stay put, right? Because I only divided them all by 1, which stays the same. Our variables, we just took 1 g away from them all. So all of the exponents are just going to go down by 1. So in the first term, if I take 1 g away, I've got g to the 3rd power. Second term, I've got plus 24. Instead of g to the 3rd power, g to the 2nd power. Third term, plus 12, take 1 g away, now we just have g. Last term, take its only g away, now we just have negative 4. Okay, so this is my factored form. This 1 in front of the first g, I don't even need to write. I'm actually going to use that to make my box. You can have it, you don't have to. Not important. So this is what I think the answer is. So now we're going to go ahead and check by distributing. G times g cubed plus 24g squared plus 12g minus 4. To check, we're going to distribute this back in, this g. Remember the g that we have right here already has an exponent of 1. You can put that in any of your variables that don't have exponents. Remember when you multiply variables, you add exponents. So g times g cubed is g to the 1 plus 3, or g to the 4th power, plus g times 24g squared. We're going to add the 1 and the 2 and get 24g cubed. G times 12g. We're going to add the two 1 exponents, so 12g squared. And then the last g times negative 4g. So we're going to compare this to what we started with. They are exact, so that means our factored version was correct, and the GCF, the greatest common factor, was that g that we pulled out. And here's the last example. This one may look a little different because we have two different variables. We'll just do each variable one at a time, but the process is exactly the same. So let's go ahead and first start by looking at our coefficients, 6, -3, and 9. Whenever you're pulling out the greatest common factor, don't worry about pulling out a negative. Just leave the signs where they are and just pull out the actual number part. Okay, so let's look at 6, 3, and 9. Think about all the numbers that you can multiply together to make those numbers. I noticed that they all have a factor of 3. I can multiply 3 times 2 to get 6, 3 times 1 to get 3, and 3 times 3 to get 9. So I'm going to pull out a 3 as the number part of my GCF. Now I'm going to look at the variables. Let's focus on just the x's first. I've got x squared, I've got x to the 1st power, and I've got x to the 3rd power. The most x's that all three terms have is 1x. Now I'm going to look at the y's. I've got in the first term, I've got y to the 1st power. In the second term, y to the 2nd power. In the last term, y to the 1st power. So the most y's that every term has is just one y. So my GCF is 3xy. Now I'm going to put what's left, the factors that are left, in my parentheses. All right, let's look at the number part for the first term. 6 divided by that 3 is 2. I took 1x and 1y away. I took 1x away from 2x's, so I've got 1x left, and I took my only y out. So all I have left is 2x. Second term, 3 divided by 3 is 1, so I just have minus 1. I can or can't put the 1, it doesn't matter because it's a coefficient. I took the only x away, so there's no x's left, and I took one of the two y's, so there's one y that's left. So like that. Now I don't have to do either of those ones, I can just write minus y. Last term, 9 divided by 3 is 3. There's the number part. I took 1x away from the 3x's, so there's 2x's left. And I took the only y away, so there's no y's left. So this is what's left. This is the factored form. Or this is what it looks like when I pull out the GCF, or the greatest common factor, of those three terms. Last thing we've got to do is check. Rewrite the answer that you think it is, 3xy, parentheses, 2x, minus y, plus 3x squared. To check it, we're going to simplify by distributing that 3xy. When we multiply variables, we add exponents for the same variable. Just keep that in mind. So when I do 3xy times 2x, the 3 times 2 is 6. I can add the 1 and the 1 on both the x's to make x squared, but the y, there's not another y, so I'm just going to bring it down. Okay? 3xy times negative y. Well, 3 times a negative is going to be negative 3. I only have one x, but now I've got two y's, so I'm going to add the 1's for both of those y's and make y squared. Last, 3xy times 3x squared. 3 times 3 is 9. I'm going to add the 1 and the 2 exponents on my x to get x to the 3rd power, and then I've just got a y. So I'm going to compare this simplified version to what I started with, and yep, they look exactly the same. So that means I correctly factored this. Okay? So, a couple things that you might find when you're practicing. sometimes you'll factor out a number that works. Let me show you what I'm talking about. Let's go back to this example 2. Let's say in the beginning, I didn't do this. I had factored out a 2x initially. Because 2 is a factor of both 4 and 24, but it's not the greatest factor. So let's say I pull out a 2 instead. And this is what, whoops. And so what I get 2x minus 12. Okay? So this is the wrong answer. But when I check it, I still get 4x squared minus 24x, which is right. So sometimes your factored version will not be right, even though when you check it, it's correct. And all that means is that this number in front, the GCF, wasn't the greatest common factor. It was just a common factor. So that's the most important part right now, is making sure that you're getting the biggest common factor, not just a common factor. All right, good luck. Let me guys know if you have any questions.